Okay, so I will start. So here the signals, discrete time signals, we are given. Okay, xn cos phi by 3n sine phi by 4n. So you can see that this is composite signal. Okay, that means two cos term, one cos term and one sine terms, okay, combine to form this signal, no? Okay, so you can see that the signal is a combination of this part, this signal, and also this signal. Okay, so to determine the Fourier series representation, what you have to first verify, you have to verify this is periodic. Okay, this is periodic or not. Then what is the period? So this is the thing you should know. You should first identify it. Okay, so I hope you can do this, because many questions we have done in case of continuous time signal. Okay, this kind of question, many questions we have done, okay, we have solved in case of continuous time signal. Okay, but in the case of discrete time signals also, it is not much different. Okay, the same procedure uh, we have to take. Okay, we have to follow. Okay, so what is that procedure? So can you guys hear me and see my screen? Hello?
Yes, sir.
Okay, thank you. So so you can see that this is a sine cosine signal and this is a sine signal. So basically you know this, every sine and cosine signal, sinusoidal signals are periodic, no? Okay, so you know that. Okay, or any sinusoidal signals is a periodic signal. We have already learned that. Okay, so you can get that fact directly here. You no need to prove this. Okay, you no need to prove this periodic or not. You can directly get that fact. Okay, so I will get that fact. Okay, so you know that this is periodic and this is also periodic. So what is the period here? So you know that this is the fundamental frequency, no? Okay, so if the signal is in a cos omega naught n plus phi or something, if our signal is in, okay, whether this is continuous signals or discrete signals, no matter, this is the amplitude, okay, and this is the phase shift of the signal, okay, this is cos, okay, and this omega naught is the fundamental period, fundamental frequency. Fundamental frequency, you already know that. Okay, so what is the fundamental period? N naught. N naught is 2 phi by omega naught, no? So we can express omega naught is equal to 2 phi by n naught. Both are correct. So we already know this. Okay, so you should know this. මේක තේරෙනව නේද ඔකට? මේක අපි use කරා ගොඩක් පාරක්. ඒකින්ද දැන් මේ වගේ දේවල් ඔකට එකේ ඔළුවට මේ කා වැදිලා තියෙන්න ඕන. හරි. So I hope you can remember this. You should remember this in your exam paper also. You have to use this knowledge. Okay. Okay. So you have to keep this in your mind. Okay. So we will apply this. Okay. So you know that for the signal, okay, for the signal, let's say it is x1n plus signal and this is x2n. Okay. So if you consider x1n, okay, x1n, x1n, okay, what is the period? Fundamental frequency, that is 5 by 3. Okay, that is 5 by 3. And if you want to find the period n naught, okay, here let's say it is n1. Okay, n1 is 2 5 by 5 by 6, no? So 5 will cancel. So you will have 6 here. So in 1 is 6. Okay. So for this signal, this is the fundamental period. It is a number of samples. Okay. So in continuous time signal, this is time S. Okay. In case of continuous time signal, but here it is number of sample. Okay. So you already know this. So here, so this is the first signal period, fundamental period. Okay, so same as let's take x to n. Okay, so guys, tell me what is the fundamental period here for this x2? Tell me. What is the fundamental frequency? You have to see and tell me. Just tell me. What is the fundamental period of this signal, sine signal? Fundamental frequency. Tell me, anyone. Just tell me the value. What is the fundamental frequency of this signal? Here it is 5 by 3, no? For this signal, 5 by 3. And what is the one? Yes, thank you. Very good. 5 by 4. It is 5 by 4, no? So this is our fundamental frequency. Okay. So that means how to find the period. So already you know that period is yeah, thank you. Yeah, Sasi, the period should be 8, no? Yeah. So let's calculate anyway. So you can see that it is 2, 5, okay, 2, 5, 5 by 4, that means 8. Okay, so the period is here 8. Okay, so can you remember how to find the, so here, this is the period of this signal. Okay, this is the period of this signals, 6, no? And 8 is the period of this signal, second signal. Okay, so can you remember how to find the composite signal period? Can anyone tell? What we have to get? What we have to check? Can we remember that we will get a ratio? No, we will get a ratio, and we check that that ratio is a irrational number or rational number. By that we have decide whether that composite signal or signal is periodic or not. Can you remember? So what is the ratio we should take? Just tell me. You can use the notation. Here we have N1 and N2. So what is the ratio we should take? What is the ratio we should take? We should take N1 by N2, no? This is the ratio, no? The ratio of two fundamental period of two signals. Okay, so we have to get this ratio. Okay, and if the ratio is check what is the ratio. It is 2 by 4, no? Yeah, sorry, 3 by 4, no? It is 3 by 4. So 6 by 8 means 3 by 4. So this is the ratio, no? So what is this number? It is a rational number, no? Because we can express this as a ratio. So 3 by 4 is a rational number. Okay, so this is a rational number. Okay, so this is a rational number. So we can set that this is periodic, no issue, periodic, because this is a rational number. So we can directly say this is periodic. We already know that this is periodic, no? Because if two signals are periodic, then most probably the signal will be periodic, okay? But every time it is not happening, okay? In case of sinusoidal and cosine signal, most probably that is happening, okay? So here you can see that we have a ratio. That ratio is a rational number, so it is periodic. So we know that the signal is periodic. So what is the period? So you know that N1, 4N1 is equal to 3N2, okay? So what is the period here? So can anyone tell what is the period? You can type in the chat. So what is the period here? You have this N1. So what is the value here? What is the value here we get? You already know this N1 and N2. No, it is 6 and 8. So what is the value here? We will get 4N1 equal 3N1. So what is the value here? What is the value here? You can substitute any value. You know N1 and you also know N2. So you can substitute any value. Yeah. Yeah. Thank you. 24, no? Yeah. 4 by here you can put here if you want N1 is 6. Okay. So you already know N1 is 6. Okay. And N2 is 8. Okay. So 4 by 6, 3 by 8. Sorry, 4 into 6, 3 into 8. So you will get 24. Yeah, you will get 24. So this is the period of the total signal. Okay. So we have already find the period. Okay. And if you want to find the fundamental frequency, you can use that notation, no? Okay. So you already know that omega naught is equal to 5 by omega n naught. Okay. So you can use this fact to calculate the fundamental period omega naught for the composite signal xn. Okay, for composite signal xn, the fundamental period, let's say it is n naught. Okay, I get it as n naught. Okay, n naught is 24. Fundamental period of this xn signal of a composite signal, and in same manner, omega naught is equal to 25 by 24, 25 by n naught, that means 25 by 24, that is 5 by 12, no? So this is the period. Sorry, this is the fundamental frequency, and this is the fundamental period. Okay, so we have, we got that fact. Okay, we got that fact. Then we will move. Okay, so we know that now we know the fundamental period. Then this has a cosine and sine signal. So rather going through that our principal approach, that means this approach. Okay, you can use this approach, no issue, but you have to do some calculation and many things here. Okay. But if the cosine and sine wave, sine signals are there, you can directly find this. No, so how can you find this? Okay, how can you find this? So you know that if the, so we have xn is equal to cos 5 by 3n, cos 5 by 3n, and sine 5 by 4n. Okay, this is our signal, composite signal, and we know this signal period and this signal period, so that we have find the total period of this signal, that is 24. Okay, and the fundamental frequency for this composite signal is 5 by 12. Okay, So you know that we have here cosine and sine wave. Okay, cosine and sine wave. So we can directly express these two terms in exponential terms, no? So you know that Euler formula, j theta is equal to cos theta plus j sine theta. Okay, and e to the power minus j theta is equal to cos theta minus j sine theta. So if you want to get the cos theta, so you can just add these two equation. Then this sine j sine theta cancelled out, and you will have 2 cos theta is equal to 2 cos theta equal e to the power j theta plus e to the power minus j theta. Then if you want to find the cos theta, you can divide it by 2, no? So here we have e j theta by 2 plus e to the power minus theta by 2. In same manner, if you want to find the sine terms, you can simply reduce. You can subtract 2 from 1. Okay. Then you have cos t cancel out. Okay. Then you have j sine theta minus j sine theta. So you have 2j sine theta. Okay. So 2j sine theta is equal to addition, the subtraction of these two terms. Okay. So if you want to find the sine theta, so simply you can divided it by 2j. No. So here you have e to the power j theta by 2j minus e to the power minus j theta by 2j. Okay, so this is a cos value, this is a sine value. Okay, so you can remember this. Okay, I always tell, if you go through this procedure and get the result, it is good, because very little thing then you have to keep on remember. Okay, so using the fact you have already already got in your mind, you can use them and you can use them and analyze them and get the answer. Okay, so and the other way is, the short way is, these things also you can keep in remember, this one and this one. Actually for me, I have done many questions. Okay, but still I couldn't remember this and this. That is why I always write it in side and do it. Okay, calculate it. Okay, so yeah, so sometime it is not good for exam, because we have to take some time here also. Okay, so for the exam, if you can keep remember these things, it is much easier. So you can use directly, no? Okay, if you familiar with this, okay, so you can write it directly, no need to do this the side calculation. Okay, you can directly write this. Okay, so I don't know if you can remember it. Sometime it may be better. Okay, so I can write anyway this xn as using this exponential terms. Okay, exponential terms, like here cos 5 by 3, I can write it as 1 by 2. Okay, 1 by 2 e to the power j, here it is 5 by n, no? 5 by 3n. Okay, e to the power j 5 by 3n plus 1 by 2 e to the power 5 by 3 minus 5 by 3n plus, now I have write the sine term. Okay, this term I have complete, this is sine term, and then I have to write this cos term in terms of this complex terms. Okay, so here we have e to the power j theta. Here theta is 5 by 4n. Okay, 5 by 4n, okay, by divided by 2j minus e to the power j minus 5 by 4n divided by 2j. So this is cost term. No? So already I have tried this in terms of exponential terms. Okay, so if you compare this one with the representation of signal, okay, so it is like this, no? K within n naught, okay, k within n naught, ck e to the power jk omega naught n, like this. Okay, so if you write this xn in terms of this ck, so you will have this kind of series, no? If you let's say it is c0, k is equal to 0, okay, that means c naught here. Here k is 0, that means e to the power 0, so you will have 1. So only c naught value is here. So let's say at c1, okay, so c1 it is e j, here k is 1, omega naught n, and if c is 2, c2 e to the power j 2 omega naught n, so on. No? So you will have this kind of terms if you represent any signal in a Fourier series representation. Okay, now you can compare this term, this xn with these terms. Okay, so what you can see here. Okay, here also you have collection of exponential terms, no? Collection of exponential terms, like in here, no? Here also we have collection of exponential terms, and it is weighted with some coefficients. And here also you can see that some coefficients, these terms also weighted with the coefficients. Okay, like this. So you can see that this one and this one is same. Okay, so you can say that this is the complex exponential representation of xn signal, this signal, no? So you can directly say this, no need to do anything, no? So now we have expressed this xn, so xn originally in cos and sine terms. Now using Euler formula, we have expressed this xn, this signal, xn signal, in terms of exponential terms, no, exponential, complex exponential terms. So that is the complex exponential Fourier representation of any discrete signal. So we already have done this. Okay. So this is the Fourier series representation of xn. Okay, so we have solved that. So then we have to find the coefficients. No? So we have to find the coefficients. So here it has c naught. Okay, here the coefficient is c1. Here the coefficient is c2. So on. Okay, so up to this level, do you guys have any comment or any problem? One or two guys already. If one or two or three guys understand this procedure up to this level, okay, you can tell yes, because the other sometime other your friend is still can't understand, couldn't understand this. So sometime your friend can, then if you can understand this, okay, then your friend can ask from you, no? It is more comfortable sometime, right? Sometimes they may be comfortable with you, more comfortable with you, okay, rather than talking with me. Okay, so you can say yes, I understand. If one or two guys understand, just tell me. Did you understand up to this level? Because you have to understand this, because you have exam question will come. Okay, this kind of exam question will come definitely. So anyone is there? So කට්ටිය මේක තේරුණා නම් කියන්න. තේරුම් නැත්තම් නෑ කියලා කියන්න. මෙතෙන්ට එනකල් තේරුණා නේද? අපි මේක මාළුකු දෙයක් නෙවෙයි කරේ cos එකයි sin එකයි ඊවල ෆෝමියුලා දාලා complex exponential terms වලින් ලියාගත්තා. හරි. එතකොට අපි දන්නවා සාමාන්‍යයෙන් අපි සිග්නල් එකක් Fourier සිග්නල් එකක් complex exponential වලින් represent කරන්න කියපුවාම මේ වගේ terms ටිකක් නේ අපිට එන්නේ. මෙන්න මේ වගේ terms ටිකක් එන්නේ. ඒ terms උත් මොකද? මොනවද? ඒවත් complex exponential terms නෝ තමයි. weighted මොකක් හරි coefficients එකකින් වැඩි වෙච්ච එක. නේ? මහ ලොකු දෙයක් නෙවෙයි. දැන් එතකොට අපි මෙතන Euler formula එක ලියපු ගමන්මත් අපිට ඇවිල්ලා තියෙන්නේ complex exponential terms ටිකක් මොනවා හරි මේ coefficients ටිකකින් වැඩි වෙලානේ weight වෙලා. හරි? ඒ කියන්නේ අපිට කෙලින්ම මෙතන කියන්න පුළුවන් මේ xn වල discrete complex exponential Fourier series එක තමයි මේ කියලානේ. හරි? So I hope you understand. Okay. So I hope up to this level you can do this. Okay, because we didn't do much things. We just apply the Euler formula here. Okay. So let's then what is our main target? We have to calculate this coefficients. Okay, we have to find this coefficient. So here also we have to find the coefficients. Okay, what is this coefficients and what is this coefficients? What is this coefficients? You know. So you can see that here you can see that you have omega naught. No, you have omega naught, and if you find another terms, it is C3 e to the power 3 omega naught n, and you have omega naught here. But here it is not like that. Every terms are not omega naught. No, so this is not omega naught, this is not omega naught, this is not omega naught, this is not omega naught. So first thing we have to do is convert this term into omega naught, our fundamental period. Okay, so what is our fundamental period? It is 5 by 12. This is our fundamental period. No, 5 by 12. So we can write these terms. Okay, these terms also with 5 by 12. Okay, so I have write this here half. Okay, I will use another color here. Okay, I will use that color. Okay, so xn is there. Okay, so here half is there. Now e to the power j 5 by 3, but actually we have 5 by 4. Okay, so we have 5 by 12. No, this is the omega naught. So 5 by 12 is there. Here 5 by 4. Okay, but we should be here. The 3 should be here. No, otherwise this terms not tally. Okay, so I will multiply this by 4. Okay, then 4 by 12 again it will have 5 by 3. No, so anyone have problem with this? May අපි continuous time වලත් හදලා තියෙනවා. We have done this for continuous time signal. Okay, so කාට හරි මොකක් හරි ඔකට ප්‍රශ්නයක් තියෙනවද? මේ ලියාගත්ත එක. ඇයි මම මෙහෙම ලියාගත්තේ? ලියාගත්තේ වෙන මොකුත් හින්දා නෙවෙයි. මේකේ තියෙන omega naught terms. හරි? මේකේ තියෙන omega naught terms. ඒ කියන්නේ fundamental frequency term. හැබැයි මේකේ තියෙන්නේ fundamental frequency term නෙවෙයි. හරි? එහෙනම් මම මේක ලියා ගන්න ඕන fundamental frequency term වලින්. එතකොට අපේ signal එකේ fundamental frequency එක තමයි අර cos 5 by 3 and sin 5 by 4 in signal එකේ fundamental period එක එන්නේ 5 by 2 එක. හරි? මම එහෙනම් මේක ලියා ගන්නවා 5 by 12 කියලා. හැබැයි මෙතන 5 by 12 වුණොත් මේ දෙක tally නැහැ නේ. මෙතන තියෙන්නේ j by 3 නේ. 5 by 3 නේ. මම මෙතන 5 by 12 කියලා ලියාගත්තොත් ඒ දෙක tally වෙන්නේ නැහැ නේ. එහෙනම් tally කරන්න මම ඒක 4ෙන් වැඩි කරනවා. එතකොට 4 12 කැපිලා එතන 5 by 3 වෙනවනේ, ප්‍රශ්නයක් නැහැ. Okay, so I hope you get it. Okay, I will write the other terms also. Here also half e to the power minus 4 j 5 by 12 n. plus 1 to j e to the power here 5 by 4, and I have to write 5 by 12. Okay, to get 5 by 4 again, I have to multiply this by 3. Okay, okay, j3 5 by 12 10 plus, sorry, minus, here it is minus. Okay, so minus half j e to the power j minus j3 5 by 12 n. So we have write this in terms of omega naught term. Okay, so we have omega naught 10 here, omega naught 10 here, omega naught 10 here. So if I write this again using omega naught, okay, so you can see that here it is like this, no, j 4 omega naught n, correct? Okay, and plus here half e to the power j, here minus, so I will put minus here, minus 4 omega naught n plus 1 by j e to the power j 3 omega naught n, correct? Okay, minus 1 by 2 j e to the power minus j here, so I will put minus into this 3 omega naught 10. This omega naught is 5 by 12. Okay, this 5 by 12 I write it as a omega naught, not much thing doing here. So this omega naught is actually 5 by 12. Okay, it's 5 by 12. Okay, and this one also 5 by 12, and this one also 5 by 12, and this one also 5 by 12. Okay, so already, so you can see now this is j omega naught 10, and it is multiplied by 4. Okay, so you can see that when you apply here C3, if you find the C2 coefficient C2, then here it is 2, no? Okay, so if you apply the coefficients n, ck n, okay, cn, okay, then e to the power a, so this is capital N, let's take capital N, e to the power n omega naught n, no? Okay, so this C coefficients and this one is same, no? Correct? එහෙනම් මේක තමා equal වෙන්නේ cn ට නේ. So here it is C4. Okay, so what is this term? Here it is, the value is 4. That means k value is 4. That is, here we have C4. Okay, and here you have C minus 4. Correct? And here you have C3. And what is here? You have, what is here? C, what is the value here? C value, the coefficient's value. What is that? Tell me. So what is the value here? What is the value here? Anyone? Hello, can you hear me? Hope you are there. So what is the value here? Okay, you can put it in chat if you couldn't. If you don't like to talk with me, you can put it in chat box. Tell me, what is the C value here? Is it C minus 4, C minus 2? And no, not 3. What 3? Ilan, what is the 3 here?
Minus 3.
Yes, minus. Thank you. It should be minus, no? Yeah, that's okay. Okay. Here it is minus 3, no? Now we have find the coefficients also. So you know that this one is corresponding to C4. Okay. And this is corresponding to C minus 4. This is corresponding to C3. and this is corresponding to C minus 4. So what is the coefficients actually? So coefficients is this, no? So this is the C4, this one, this coefficients, okay? And this is the coefficients C4, okay? And this is the coefficients C3, and this is the coefficients for C minus 3. So if I write it, C4 is equal to half, okay? And also C minus 4 is equal to half, okay? And C3 is equal to 1 by 2j, and C minus 3 is equal to minus 1 by 2j, correct? So these are the coefficients, okay? So this kind of questions you should be able to do okay? So try to discuss these things with your team member, okay? And we will start the session again at 4:30 after 8 minute break, okay? We will start the Fourier transform, okay? So I hope today you doesn't have any lecture, no?